What is a high-frequency, HF, wave?
Frequency 3 MHz 30 MHz.
What is a focal point?
Location where light rays from a very distant object are reflected from a mirror or refracted by a lens to come together.
How can you check to make sure a pair of sunglasses is polarized?
Polarized lenses are transparent only to light that has its electric field oriented in one direction. Therefore, if a pair of sunglasses is polarized, two pairs of the same sunglasses, when aligned perpendicular to each other, should not allow any light to pass through the lenses. Light from the sky is also partially polarized due to the scattering of light off gas molecules in the atmosphere. So if you put on a pair of polarized sunglasses and tilt your head so that your ear were near your shoulder, you should see a change in the intensity of the sky on a clear, sunny day. If you see no such change, then the sunglasses are not polarized.
How can temperature be controlled?
A device that maintains a constant temperature is called a thermostat. A traditional home thermostat contains a coiled bimetallic strip. When the temperature drops below a set point, the strip trips a switch that turns on the furnace. More modern home thermostats use an electronic thermometer and electronic circuits that turn the furnace and air conditioning system on and off.
Who defined or developed the meter?
In 1798, French scientists determined that the meter would be measured as 1/10,000,000 th, the distance from the North Pole to the equator. After calculating this distance, scientists made a platinum iridium bar with two marks precisely 1 meter apart. This standard was used until 1960. Today the meter is defined using the second and the speed of light. 1 meter is the distance light travels in 1/299,792,458 seconds.
How do convection currents create sea breezes?
During a day at the shore, the sun warms the ground and the water. The ground has a lower specific heat and so its temperature increases more than the temperature of the water. The ground heats the air above it, which rises in convection currents, and cooler air from over the ocean flows toward the shore to fill in the gap left by the rising warm air. This flow of cooler air from the ocean toward the shore creates what is known as a sea breeze. In the evening, when the sun dips below the horizon, the ground cools faster than the water. Therefore the air over the ocean is warmer than the air over the shore, and the reverse takes place. The warmer ocean air rises while a breeze flows from the shore to the water.
What is potential difference or voltage?
In a voltaic pile, today more commonly called a battery, chemical energy is converted into increased energy of electric charges. Positive charges at the positive terminal of the battery have a greater energy than those at the negative terminal. The quantity that is important is not the total energy difference of charges at the two terminals of the battery, but the energy difference divided by the charge. This quantity is called the electric potential difference, or more commonly, the voltage.
How could you arrange the location of the pivot to make the mechanical advantage less than 1?
Look closely at a pair of scissors. Note that you can adjust the mechanical advantage by moving the region of the scissors you are using to cut.
What speed would a stationary observer measure?
Surprisingly, she would find that the light was traveling at the speed of light, not the sum of the speed of the spaceship and the speed of the laser light as measured by the traveling person. That is, the speed of light is the same in all frames of reference. This is another of the results of Einstein's special theory of relativity. It has been tested, not with spaceships, but with gamma rays emitted by subatomic particles moving near the speed of light.
What is a decibel, dB?
Unit of relative intensity of sound.
What is a light interference?
Light waves from two closely spaced slits or two surfaces of a thin film that produces regions of bright and dark regions.
What is a compass?
Magnetized pointed metallic pointer that can rotate about a low friction pivot point.
What is resonance and how can it be achieved?
All objects that can vibrate have a natural frequency of oscillation. If you hold one end of a ruler on a desk and push down and then suddenly release the other end, you will see it vibrate. The natural frequency depends on the material and its width, thickness, and length. Resonance occurs when an external oscillating force is exerted on an object that can vibrate. When the frequency of the external force equals the natural frequency, then the amplitude of the oscillation reaches a maximum. This condition is called resonance. A very small external force is needed to create a large oscillation amplitude. You can explore resonance with a mass, like a yo-yo or a heavy metal washer on a string. Hold the top of the string still and pull the object to one side and watch it oscillate at its natural frequency. Then shake the top of the string at the same frequency and watch the amplitude of the oscillation increase. You will have found the resonance frequency. If you raise or lower the shaking frequency, you'll find that the amplitude of the oscillation is smaller.
What is a proton?
Positively charged particle in nucleus.
What is a lever?
Simple machine consisting of a rigid bar that pivots. 3 different classes.
Can quarks be free, or are they always bound in the proton or neutron?
There have been many searches for free quarks, but they have never been observed. The theory that describes the interactions between quarks and gluons. Quantum chromodynamics, QCD for short, says that quarks can never break free because the more that the gluons are stretched, the stronger the force they exert. In this way they act like springs whose force also increases the more they are stretched.
What is the optimal shape of a concert hall?
Building a concert hall is a mixture of science, engineering, art, and politics. Politics is important because the people who provide the funds have goals for the use of the hall. Consider, for example, the history of Philharmonic Hall in Lincoln Center, New York City. It was originally designed to be similar to the Boston Symphony Hall, long and narrow. But, a campaign led by one of the major newspapers in the city argued that the hall should seat more than 2,400 people, and so the architects made the hall wider. But when it was completed in 1962, critics were very unhappy with the sound. The wider hall did not have enough initial reflections and sounded dry. It was equipped with clouds, reflectors hung from the ceiling. But reflections from them were too delayed to be effective. Another problem was that performers on the stage couldn't hear each other.
What is a maglev?
Magnetically levitated trains that use electromagnetic forces to lift the cars off the track and propel them along thin magnetic tracks.
What is absolute zero?
Temperature at which molecular motion is at a minimum.
What is a torr?
Measure of pressure using measurement of height of mercury in a glass tube that would create a pressure that balances the pressure of the fluid. Used to be called millimeters of mercury, mmHg.
What is an optical fiber?
Strands of glass that use the principle of total internal reflection to transmit information near the speed of light.
Why do electricians work with one hand behind their back?
When working on high voltage circuitry, many electricians like to place one hand behind their back because this way there is little chance for each hand to touch objects of different electrical potentials and cause a shock.
What is the Leyden jar?
Water can be stored in a jar.
What is an ampere, A?
Unit of measure of electric current. Equal to 1 coulomb of charge passing through a wire divided by 1 second.
What is angular velocity, CO?
Equivalent of velocity for rotational motion.
What are vocal cords?
Or vocal folds. Vibrating source of the human voice.
What are difference tones?
Difference tones are frequencies that are produced as a result of two different frequencies mixing with each other. This mixing can only occur if a device is nonlinear. That is, if the output is not a multiple of the input. You can create difference tones with two toy slide whistles. Place both in your mouth and blow hard. Adjust their length so that the two tones are the same pitch. Then adjust one. As you move its pitch away from the other, you will hear a low-pitched sound whose pitch increases as the two whistles' pitches get further apart. For example, if the high-frequency sound was 812 Hz, while the lower frequency was 756 Hz, the difference tone from the interfering sound waves would be 144 Hz. The nonlinear device in this case is your ear.
How does gravity cause tides?
As someone who lives near an ocean will know, there are 2 high tides and 2 low tides each day. They're not at the same time each day, but depend on the phase of the moon. The heights of the tides vary over the seasons as well.
What is the structure of the atom?
Thomson pictured the atom as a swarm of electrons in a positively charged sphere. This model is called the plum pudding model, after a then-favorite English Christmas treat. Americans might picture a ball of pudding filled with raisins. The New Zealand-born physicist Ernest Rutherford, 1871 to 1937, developed a method of testing Thomson's model. Rutherford's first scientific work was done in Montreal, Canada, beginning in 1898. He and Frederick Soddy conducted a study of radioactivity and radioactive materials that won Rutherford the 1908 Nobel Prize in Chemistry. Those experiments will be described in the chapter on nuclear physics, at the heart of the atom. He studied the radiation emitted by thorium and uranium, which he named alpha and beta rays. He recognized that alpha rays would be ideal probes for studying materials. Rutherford moved to the University of Manchester in Britain in 1907, where he worked with Hans Geiger. 1882 to 1945, later to invent the Geiger counter, on ways of detecting individual alphas. They determined that the alpha particles were doubly charged. They allowed the alphas to go through a window made of very thin mica, a mineral that could be cut into very thin slices. He noticed that the rays that penetrated the mica were deflected slightly more than they should have been by a plum pudding atom. With Geiger and Ernest Marsden, he directed a beam of alphas on extremely thin foils of gold. To their great surprise, they found a significant number of alphas were deflected into very wide angles, some greater than 90 degrees. Rutherford commented that it was as if a 15 shell from a naval cannon bounced off a sheet of tissue paper. The Rutherford model, as pictured above, is used in many common symbols, like that of a nuclear power plant or the flag of the International Atomic Energy Agency. By 1911, Rutherford had developed his own model of an atom. It consisted of an extremely small positively charged particle, later called the nucleus, surrounded by electrons. Although the paths of the electrons were not mentioned in the 1911 paper, it was later assumed that they orbited the nucleus as planets orbit the Sun. The nucleus was 1/10,000 as large as the atom, but had all the positive charge and essentially all of its mass. If the atom's mass was equal to n hydrogen masses, then the nuclear charge was about n/2. The electrons carry a total charge equal and opposite that of the nucleus, so that the atom would be electrically neutral. Rutherford's atom is mostly empty space.
What is a position?
The location of an object requires a reference location, vector.
What does momentum mean in physics?
Momentum is defined as the product of mass and velocity. Momentum is a vector quantity. It has both magnitude and direction. Consider a football player, a lineman. Linemen are massive if they can run fast. Then the product of their mass and velocity is their momentum, mu. The momentum is in the direction the player is moving.
Why is noise pollution dangerous?
In the past, noise pollution was only thought to create health effects if the intensity was large enough to cause hearing damage. Studies over the past several decades, however, have found that long-term exposure to noise can cause potentially severe health problems in addition to hearing loss, especially for young children. Constant levels of noise, even at low levels, can be enough to cause stress, which can lead to high blood pressure, insomnia, psychiatric problems, and can even impact memory and thinking skills in children. In a German study, scientists found that children living near the Munich airport had higher levels of stress, which impaired their ability to learn, while children living further from the airport did not seem to experience the same problem.
What is the weak nuclear force?
Cause of beta decay. Weaker than strong nuclear force. Shown to be an aspect of the electroweak force carried by the massive W+, W-, and Z degree particles.
What is opaque?
An object that allows no light through it.
How does an FM band station transmit stereo sound?
Stereo sound means that two separate sounds, the left L and right R, are produced from a pair of speakers. Because stereo broadcasts must also be usable by receivers that cannot reproduce stereo, the signal that all receivers can detect consists of the sum of the left and right channels, R and L. The difference of the two channels, R, L, is broadcast 38 kHz above the R and L signals. Mono receivers can't detect these very high frequencies. The stereo receiver, though, can, and from the R and R, L signals creates separate R and L signals to be amplified and sent to the corresponding speaker. FM stations have enough bandwidth to accommodate a third signal. This signal can be sold to users to provide background music for stores or elevators. Education stations can deliver lessons to schools, or broadcasts in a second language.
What is temperature?
A quantitative measure of hotness. The more thermal energy an object has, the higher its temperature.
What is gravitational field energy?
Energy stored in the gravitational field when an object moves away from the larger object that is attracting it.
How are the results of collisions in accelerators detected?
A collision between two protons or a proton and antiproton can produce a large number of particles of different kinds. The task of a detector is to find the direction in which each particle is going, find its charge, momentum, and energy, and identify it. Detectors are huge devices. The CDF Collider detector at Fermilab weighs 5,000 tons and is 12 meters, 39 feet, in each dimension. It is operated by a collaboration of about 600 physicists from 60 universities and organizations. Atlas, a toroidal LHC apparatus, at LHC is even larger. It weighs 7,000 tons, is 44 meters, 144 feet, long and 25 meters, 82 feet in diameter. 2,000 physicists are involved in building and operating this experiment. In both detectors, position detectors locate the particles close to where they are produced in the beam line. Somewhat farther away from the beam line, a strong magnet deflects the paths of charged particles. Outside the magnet are additional position detectors and finally detectors that measure the energy of the particles. The curved paths charged particles take in the magnet are used to find their charge and momentum. Each collision can produce billions of pieces of data, only a small number of which are interesting. Electronic circuits and fast computers use data from the position detectors to decide whether the set of data are interesting enough to be recorded. Atlas produces 100 megabytes of data each second. The entire LHC produces 4 gigabytes of data each second. Enough to fill a DVD disc. Up and down respectively. The proton is composed of 2 up quarks and 1 down quark, while the neutron is composed of 1 up and 2 down quarks. You can check to see that the charges of the quarks add up correctly. Up and down quarks are said to be 2 different quark flavors. Because the quarks have half-integral spin, like electrons and neutrinos. There cannot be 2 identical quarks that have the same quantum properties. Quarks have additional property called color charge that can be red, green, or blue. A proton or neutron must have quarks with 1 of each of the colors so that they add to white. Just like ordinary colors do.
Could antimatter destroy the Vatican?
In Dan Brown's novel Angels and Demons, physicists at CERN use the LHC, the Large Hadron Collider, to produce 1/4 gram of antimatter. The material was stolen in order to destroy the Vatican. It is true that if 1/4 gram of antimatter were to completely annihilate with 1/4 gram of matter, the amount of energy produced would equal that of the bomb that destroyed Hiroshima. But, in over 10 years of experimental production, only 10 million antiprotons have been trapped and stored for times ranging from seconds to months. 1/4 gram is 1016 times as many antiprotons. Further, the antiprotons must be stored in extremely cold. Totally, antiprotons are created in accelerators, where the accelerated particle is slammed into a metal target, emitting gammas that create, in this case, proton-antiproton pairs.
What is the tallest structure ever built?
Structures and towers are listed separately from skyscrapers. The Warsaw Radio Tower on the outskirts of Warsaw, Poland, was the tallest structure ever built. Although it needed to be supported by long cables to keep it up. The tower reached 646 meters, 2,119 feet, into the sky. Unfortunately, in August 1991, the tower came crashing down during repair work. The tallest structure ever built that is still in existence is the KTHI-TV Tower in North Dakota, which stands with the help of cables 629 meters, 2,063 feet, tall. The tallest self-supporting tower in the world is the Canadian CN Tower, whose tip is 553 meters, 1,815 feet, above the city of Toronto.
What is the elastic collision?
In a collision, the kinetic energy of colliding objects is the same before and after the collision.
What is aerodynamics?
An aspect of fluid dynamics dealing with the movement of air.
What plays the role of momentum in rotational motion?
The angular momentum of a rotating object is proportional to the product of its moment of inertia and its angular velocity. If there are no external torques on the object, then its angular momentum does not change. An object with linear momentum that has no external forces on it cannot change its mass, so its velocity is constant. But a rotating object can change its moment of inertia, so even without external torques, its rotational speed can be changed.
Does sound travel faster on a hot or cold day?
Air molecules move faster in hot and humid environments due to their increased thermal energy. Since sound relies on molecules bumping into one another to create compressions and rarefactions, increased speed of molecules makes the sound waves move faster. The speed of sound increases by 0.6 meters per second for every degree Celsius increase in temperature. Water vapor in the air also increases the speed of sound because water molecules are lighter than oxygen and nitrogen molecules. Therefore, on hot and humid days, sound travels faster than on cool, dry days. The following formula gives the speed of sound in air. Speed of sound equals 331 m/s, 1 plus 0.6 T, where temperature, T, is measured in Celsius.
What are ultra-high frequency, UHF, waves?
Frequency 300 MHz 3 GHz.
What is a superposition?
Two or more waves at the same location pass through each other without interaction. The amplitudes of the two waves add or subtract.
Where can resonance be found on the playground?
Children discover resonance early in life. When playing on swings, they use their arms and legs to pump themselves back and forth on the swing. They recognize that if they pull back on the chains every time the swing is at its largest backward displacement, they will achieve the largest amplitude. If, however, the pull back at other times, or if a parent pushes at the wrong time. The amplitude will be decreased because the external frequency isn't at the natural frequency.
What is air drag?
Friction caused by an object moving through air. Drag depends on velocity, area, shape, and the density of the air.
Why does a small clump of steel sink, while a 50,000 ton steel ship can float?
In order to remain afloat, a ship needs to displace an amount of fluid equal to its own weight. Therefore, if a clump of steel is placed in water, it will sink because it is much denser than water and its volume isn't large enough to displace a weight of water equal to its own weight. A 50,000 ton steel ship can easily stay afloat because it can displace 50,000 tons of water. That is because its hull isn't all steel, but contains a large amount of air. Therefore its density, its mass divided by its volume, is less than that of water.
What is an atomic mass number?
Number of protons and neutrons in nucleus.
Where do X-rays come from?
X-rays are electromagnetic waves of very short wavelength. Alternatively, they are very high-energy photons. They are emitted by atoms with many electrons, such as those high in the periodic table. The more electrons, the greater the charge of the nucleus. And the higher the energy of the electrons that are close to the nucleus, with n equals 1 or 2. Therefore, when the atom is disturbed, as it is in an X-ray tube when the anode is bombarded by high-energy electrons, one of the n equals 1 electrons can be kicked out. When an n equals 2 electron loses energy and takes the place of the kicked out electron, an X-ray is emitted.
How do optical fibers use total internal reflection to transmit information?
Strands of glass fiber, commonly known as optical fibers, use the principle of total internal reflection to transmit information near the speed of light. The fiber has an inner core of glass with a high refractive index surrounded by a cladding of glass with a lower index. A laser sends light into the end of a strand of fiber. When the light strikes the interface between the core and the cladding, the light is reflected back into the cable, continuing to move down the length of the fiber. Light or near-infrared radiation can travel kilometers through fibers without significant energy loss. One reason is the total internal reflection. The second reason is that are made from materials designed to absorb as little as possible of the infrared radiation. A second advantage of optical fibers is that information sent through the fibers is more secure, because it doesn't escape the fiber and thus be accessible to those trying to intercept the information.
What is a vector quantity?
A quantity that has both a magnitude and a direction.
How can the emission and absorption of light by atoms be explained?
In 1911 Niels Bohr, 1885 to 1962, a Dane who recently had received his Ph.D. from the University of Copenhagen, joined Rutherford at Cambridge University. He quickly began work on the Rutherford model. He published his results in 1913, basing them on three postulates. 1. Electrons only move in certain allowed orbits at discrete radii and with specific energies. That is, their radii and energies are quantized. When in these orbits their radii and energies are constant, the atoms do not emit or absorb radiation. 2. Electrons gain or lose energy when they jump from one allowed orbit to another. Then they emit or absorb light with a frequency given by hf equals E2, EI, where E2 and EI are the energies of the electrons in the allowed orbits. The constant h is called Planck's constant, 6.6 x 10 to 34 J/Hz, joules per Hertz. 3. The correspondence principle. When the electron is very far away from the nucleus, classical physics must give the same answer as the new quantum physics. He later changed the third postulate from the correspondence principle to requiring that the angular momentum of the electron be quantized, that is proportional to an integer called the quantum number. The results didn't change, but the derivation of them was more straightforward. This method is presented in almost every textbook. The two drawings below illustrate the emission of light when the electron goes from a higher energy to a lower energy orbit and the absorption of light when the electron's energy is increased. In 1885 Johann Balmer had found a formula that accurately calculated the wavelengths of the visible hydrogen spectrum. It was purely empirical, that is, there was no physics-based explanation of it. In 1888 Jan Rydberg generalized Balmer's results to allow calculation of hydrogen emission in the ultraviolet and infrared. Bohr was able to explain Balmer's and Rydberg's formulae using the results of his postulates. The equation for the wavelength of the emitted radiation is 1/x equals r, I/m2, 1/n2. The numbers m and n are the quantum numbers of the two energy levels. For example, the red line would have m equals 2, n equals 3. The constant r is 0.01097 nm1, making the wavelength of the red line 1/0.01097, V4, 1/9, nm1, equals 656.3 nanometers, in excellent agreement with the experiment. Thus Bohr's model is a major advance in understanding the structure of the atom.
What is the Van de Graaff generator?
Named after its American creator, Robert Jemison Van de Graaff, 1901 to 1967. The Van de Graaff generator has been the highlight of many electric demonstrations in both physics classrooms and museums around the world. The device, created in 1931, consists of a hollow metal sphere that stands on an insulated plastic tube. Inside the tube is a rubber belt that moves vertically from the base of the generator to the metal sphere. A metal comb attached to the base almost touches the belt. The rubber belt carries negative charges from the comb up the tube and into the metal sphere. There, a second metal comb captures the charges. They repel each other and spread over the exterior surface of the metal sphere. As more and more charge is carried upward, it takes more and more energy from the motor to move them up because of the repulsive force of the charges already there. The energy of the charges can reach up to 1,000,000 joules per coulomb of charge. That is, up to 1,000,000 volts.
Does voltage shock you?
Signs around power plants and breaker boxes often state, "Caution, high voltage area." It is not voltage that can hurt you, it is the electrical current that flows through your body that can produce serious and sometimes fatal consequences. The Van de Graaff generator creates hundreds of thousands of volts, but produces such a low amount of current that the sparks it emits only cause muscles to tingle.
What is an atomic number?
Number of protons in the nucleus and thus the nuclear charge.
What is a refractor telescope?
The refractor telescope was the first telescope ever created. It employs one lens to gather, refract, and focus light toward an eyepiece. The eyepiece contains one or more lenses that create an image that the eye can see.
What can exert a force?
The first answer that might come to mind is that a person can exert a force. He or she can throw a ball, pull the string on a bow to shoot an arrow, push a chair across the floor, or pull a wagon up a hill. Many animals can do the same thing, so one might say that living organisms can exert forces.
What is a positron emission tomography, PET?
Method of forming three-dimensional image of human body. Uses a short-lived positron-emitting isotope inserted into a biologically active molecule.
When are fusion reactors expected to generate electricity?
No one knows, but the prediction of scientists working on fusion projects that has been made every year since the 1960s is about 40 years from now.
What is a mirage?
Occurs when there is a temperature difference between the air directly above the surface, which is hot and thus less dense, and the cooler, denser, air a few meters above the surface.
What is a series circuit?
A series circuit consists of electrical devices such as resistors, batteries, and switches arranged in a single line. There is only one path for the charges to flow through. And if there is a break anywhere in the circuit, the current will drop to zero.
What is a British thermal unit, BTU?
Unit of energy often used to measure heat in homes and industries.
What is fluid dynamics?
Fluid dynamics is the study of fluids in motion.
What is the latest fusion reactor research project?
The ITER reactor project is international in scope, including the United States, Russia, the European Union, India, Japan, China, and South Korea. The plan is to spend 10 years in construction and 20 years in operation. No electrical energy would be generated. That would require a more advanced reactor. Using 0.5 grams of deuterium-tritium fuel. It is designed to produce 500 megawatts of energy over 1000 seconds. For the first time in a fusion reactor, more energy would be produced than needed to run the reactor. In May 2010, contracts were signed to construct the first buildings in the project that are sited in the south of France. Fusion reactions are scheduled to begin in 2018.
What is a Higgs particle?
Hypothesized particle associated with the mechanism that gives rise to the masses of the quarks. Leptons, and the two weak interaction bosons, the W and Z.
What is the Planck's constant?
H equals 6.6 x 1034 J/Hz.
What is interference, constructive?
Two waves both either positive or negative that add, producing a larger wave amplitude.
What is loudness?
Measure of how a listener responds to intensity of sound. Measured in sones.
Can you do it?
Standing on your toes moves your point of support in front of your center of gravity. So you will tip backwards.
What is a secondary rainbow?
The secondary rainbow has its color spectrum reversed, is outside of the original rainbow, and is significantly dimmer than the primary rainbow. A secondary rainbow occurs because an additional reflection of the light takes place inside the water droplets. Instead of reflecting once in the water droplet, the light reflects twice inside the water, reversing the order of the colors. The secondary rainbow appears between the angles 50 degrees and 54 degrees.
What are other contact forces?
You might think of rubber bands on slingshots, rods on the wheels of your car, or ropes pulling carts. Water and air can also exert a force. Think of a stick moving down a stream. Or what you feel when you stick your hand out the window of a fast-moving car.
What is thermal energy?
Thermal energy is the random kinetic energy of the moving atoms and molecules that make up matter. But objects expand when heated, so the bonds holding the atoms together stretch. That means they have more elastic energy. So thermal energy is the sum of the kinetic and elastic energy of the atoms and molecules, and the bonds that hold them together. It is energy that is inside the object, and so it is called a form of internal energy.
What is power, P?
The change in energy divided by the time taken.
What combination of charges causes attractive and repulsive forces?
As you observed, unlike gravitational forces, which only attract masses to each other, electrostatic forces can either attract or repel charges. Like charges, positive or negative, repel each other. Unlike charges, positive attract each other. A common phrase describing many human social relationships. Opposites attract, holds true for electrostatic forces.
What is a transformer?
Impedance matching device.
How did the study of beta decay result in the discovery of a new particle?
In beta decay, a nucleus emits an electron. The electron isn't in the nucleus originally, but results from the change of a neutron into a proton. Studies of the energy of the emitted electron showed that, instead of having a single energy like an alpha has, the energies of the electrons were spread from near zero to a maximum energy. Early investigators recognized that this suggested that energy was not conserved in beta decay. Austrian physicist Wolfgang Pauli, 1900 to 1958. Proposed in 1930 that a second particle was emitted along with the electron. This particle had to be neutral and zero, or extremely small mass. And he named it the neutrino, or little neutral one. The neutrino wasn't detected experimentally until 1956. We now know that the neutrino emitted in beta decay is actually an antineutrino. The question of its mass will be discussed in the chapter on unanswered questions. When a nucleus undergoes beta decay, the number of protons increases by 1 as the number of neutrons decrease by 1. So, for example, carbon 14, 6 protons and 8 neutrons, becomes nitrogen 14, 7 protons and 7 neutrons. With the emission of the beta electron, and an antineutrino.
What is friction force?
A force due to an interaction between an object and the surface on which it rests. Always in the direction opposite the motion. Depends on the force pushing the surfaces together. In most cases is larger if the surface is rougher. Generally doesn't increase if the speed of motion increases. Friction equals Nn.
What are the secondary colors?
When any two of the three primary colors are mixed, secondary colors are formed. They are called secondary because they are byproducts of the primary red, green, and blue colors. Red light mixed with green creates yellow light. Red and blue produces magenta. Finally, cyan is formed when blue light and green light are added together.
How does accuracy differ from precision?
Both accuracy and precision are often used interchangeably in everyday conversation. However, each has a unique meaning. Accuracy defines how correct or how close to the accepted result or standard a measurement or calculation has been. Precision describes how well the results can be reproduced. For example, a person who can repeatedly hit a bull's-eye with a bow and arrow is accurate and precise. If the person's arrows all fall within a small region away from the bull's-eye, then she or he is precise, but not accurate. If the person's arrows are scattered all over the target and the ground behind it, the she or he is neither precise nor accurate.
What is bronze?
An alloy of copper and tin.
What is the R value?
Measure of resistance of material to heat transfer. R is the inverse of conduction, R equals 1/U.
How do LCD devices use polarized light?
LCD stands for liquid crystal display. A liquid crystal is composed of long, thin molecules that are free to move like a liquid but organize themselves in a regular array like a crystal. In an LCD display, the liquid crystal material is in a thin layer between two glass sheets. The bottom sheet is rubbed in one direction so that the molecules in the liquid crystal touching the surface align themselves with the rubbing. The top sheet is rubbed in the perpendicular direction, aligning the molecules touching it in that direction. As a result, over the thickness of the liquid crystal material, the direction of the long axis of the molecules rotate through 90 degrees. Polarizers are placed on the outsides of the glass sheets in the same direction as the rubbing. When light enters the back of the display, it is polarized. As it passes through the crystal, its polarization direction is rotated through 90 degrees so that it passes through the second polarizer. Thus light passes through the display, it appears bright. Each glass sheet is coated with a thin, Electrically conductive layer. If a voltage is placed across the sheets, the molecules align themselves with the electric field. The molecules no longer rotate the direction of polarization of the light. So no light passes through the display. It appears dark. By varying the voltage, different degrees of darkness can be produced. An LCD television screen uses liquid crystals composed of long, thin molecules between two glass sheets. An electrical field rotates the molecules in the pixels, so that polarized light either passes through or is blocked. Color filters are added to the pixels to achieve color. The entire display is composed of tiny pixels, each connected to a source of the control voltage. Thus each pixel can be switched between light and dark. Color filters can be placed over each pixel to produce a full color display. In a 1080 pixel high definition television display, there are 1920 pixels in the horizontal direction and 1080 in the vertical, for a total of 2,073,600 pixels.
If you stand with your back against a wall, can you bend forward so the trunk of your body is horizontal?
Most likely, if you're male, you will tend to fall forward. While if you're female, you are more likely to be successful. Again, the question is whether or not the center of gravity of your body is above your point of support, in this case your toes, or in front of it.
What is a quad?
Unit of energy used for measuring energy use by nations. 1 quad is 1000 billion BTUs.
Why are electromagnets, the kind that pick up junk cars, so strong?
An electromagnet is a coil of current-carrying wire wound on an iron core that is at the center of an iron cup. The magnetic field created by current in the wire is strengthened by the iron core. The strength of the magnetic field produced by such electromagnets creates a large force, as described by the Lorentz force law, that allows people to more easily move large metal objects, such as steel cars, from one location to another.
What are some good conductors of electricity?
In order to be an effective conductor, a material must allow the electrons to move easily throughout it. The atoms in good conductors, such as most metals, have 1 or 2 electrons that can be easily freed from the nucleus to move through the material. Water is a fair conductor, but when salt is added it becomes a better electrical conductor.
How does a camera lens create an image on the sensor?
The diagram below shows what would happen if there were 3 pinholes, each creating an inverted reproduction of the object. See page 211. Now, if a converging lens is placed just behind the pinholes, it will bend the rays going through it. If the focal length of the lens and the distance between the lens and screen are chosen correctly, then the 3 reproductions from the pinholes will all be at the same location. Light rays from the top of the object will converge on the appropriate point on the image. Note that the image is inverted and the same size as the reproductions.
What is architectural acoustics?
Theaters, concert halls, churches, classrooms, and soundproof rooms have to be designed and constructed so that their acoustic properties match their uses. In some spaces it is important that the speaker, singer, or musician or group be heard clearly in all parts of the room. A good concert hall has intimacy. Music should sound as if it were being played in a small hall. It should have liveness and warmth, fullness of bass tones. The sound should be clear, and the audience should be able to locate the source of the sound. The sound should be uniform over the entire hall, and sounds from the stage should be blended by the time they are heard by the audience. Finally, the hall should be free of noise, from air handling systems as well as outside sounds. In order to achieve these goals, an acoustical engineer must consider not only the size and shape of the hall, but also the acoustic properties of materials used on the floors, ceilings, and walls of the room, as well as chairs and other objects in the room. Even the audience and air humidity affect the acoustic properties of the room. In general, hard surfaces such as concrete, plaster, wood, and tile reflect sound, while soft materials like carpet, heavy drapes, and plush upholstered chairs absorb sound. Room shapes and sizes that create standing waves should be avoided because sound at frequencies at which the standing waves occur will not be uniform. They will be loud in some places, soft in others.